Hello students, good morning everybody. In the previous class of mathematics of standard 9 CBSE, we discussed about the number system in which natural numbers, whole numbers, integers, rational numbers, irrational numbers were discussed. And we also learnt how to find rational numbers between any two rational numbers. Today we learn about the terminating, non-terminating decimals. Now I am starting at first terminating decimals. Terminating decimals are those in which the rational number numbers with a finite decimal part the rational numbers with a finite decimal part are known as terminating decimals. As for example, one by four is a terminating rational number because its result is 0.25. If you divide 1 by 4, then at first we have to put a decimal, then 0, 2 4 is 8, 4, 2 0 5, 20. This is a terminating decimal in which the terminating part of the finite number of decimals, that is 2. Here decimal parts, the number of decimals are 2, 0.2 and 5. That is why it's called a terminating decimal. What is non-terminating decimal? Non-terminating decimals are those. Sometimes we see that in a division there is no remainder. Sometimes we see that the remainder is come again and again. When the remainder is 0 or the remainder is finished or ended, then it is terminating decimal. Or when the remainder is not ended, that means the remainder is come again and again in a repeated method or repeated manner, then we call it non-terminating decimals. Like 1 by 3, it's a rational number. If we divide 1 by 3, then we have to put at first decimal, then 0, 9, then 1, then 0, then this, and so on. That means this 3 is come again and again repeated, and we write this like this. This is the non-terminating decimal because 3 is come again and again. In the same way, the digits in here in this place 3 is repeatedly come. In another method or in another decimal, this 3 it may be 0.123, 123, 123 and so on. This is 0.123. This is called non-terminating decimal. This result 0.123 is also called recurring decimals. This is also called recurring decimal. Now, how we express a recurring decimal into its simplest form. Express .003. It's a recurring decimal as a fraction in the simplest form. At first, we consider x equals to 0.003. This is 0.003, 003, 003 and so on. Infinite numbers of 003. Here the number of decimals are 3. That is why we multiply x by 1000. Now 1000 into x equals to 1000 into 0.003, 003, 003 and so on. That means this is 3.003, 003, 003. Since the number of 003 are infinite, that is why if 1003 is come here before the point, then there is no difference between this and this. There is no difference between this and this. Now we subtract. It's equation 1, it's equation 2. Now by subtracting, minus 1, 1000x minus x equals to, actually when we subtract this from this after decimal part, the decimal part will be cut. The resulting is 3. That is why 999x equals to 3. X equals to 3 by 999 equals to 1 by 3, 3, 3. This is the answer. Okay. Now we do another sum. Prove that root m is not a rational number. Now we are doing root m. Prove that root m is not a rational number. Prove that root m is not a rational number if m is not a perfect square. If m is not a perfect square. Solution. Since we have to prove m is not a rational number, that is why we have to prove m is not a rational number. That is why we assume it as rational number. Let m root m equals to p by q be a rational number. Be a rational number where P and Q have no common factor. That is, these are co-prime. Therefore, we can consider this squaring both the sides. We have m equals to p square by q square. This implies p square equals to m into q square. Therefore, m is a factor of p square. Therefore, m is a factor of p square. This implies m is a factor of p also. So, let p equals to mx. Since m is a factor of p, that is why we can assume p equals to mx. X is some integer. X is some integer. Therefore, p square equals to m square x square. P square equals to m square x square. Here, p square equals to m into q square. From start. This implies cube square equals to m square x square by m equals to m x square. That is, m is a factor of q square and hence of q. Therefore, m is a factor of q square and hence of q. Means m is a factor of q square, that is why m is also a factor of q. Therefore, from 1 and 2, therefore from equation 1 and from equation 2, both P and Q have a common factor M. M is also a factor of P and M is also a factor of Q. That therefore our assumption, because we assumed here or considered here P and Q have no common factor, but at the result, in the result, M is a common factor of P and Q, and it's a contradiction against our assumption. That is why root M is not a rational number if M is not a perfect square. Hence proved. From 1 and 2, M is a common factor between P and Q, which is a contradiction against our assumption. Therefore, root M is not a rational number. If M is not a perfect square. Okay. Thank you. This part is ended here. In another part, we will discuss about the other things of this chapter.